All right. Down here, we have our master fader, which I'll get to in just a minute, in a pan control, but we'll get to that in just a second. I want to show you an example of EQ. Let's just use a classic game, Final Fantasy 13. Great soundtrack. Masashi Hamatsu made this soundtrack, and I love it. So why don't we use this? Let's check out our EQ progression. So we can actually isolate bands in certain plugins in Reaper, and you can actually hear just certain swaths or certain frequency bands and kind of work with them in that sense. I'll show you what I mean. This is flat EQ. Slower a little bit. All right, something like this. Frequency, decibels. And here's our low band. Just the lows. All right, I can talk to you and hear me much more clearly because the speech frequencies have been removed. The lows only. And you could be tweaking these, you know, mid, much louder. Let's go back. There we go. There you have it. So we may want to sometimes hone in on certain frequency bands and adjust them without having to use the whole mix. Most of the applications we have, though, are probably going to use you know, the whole spectrum, and we can just kind of take a piece, bring it up, bring it down, attenuate it, boost or cut the signal, what we normally call it, boosting or cutting. Okay, back to the mixer. We have a pan control, very simple. Can go to the left speaker or right speaker. Straight up is the center, and that's basically it for a stereo mixer. Okay, the fader is just the master control. After I've used the gain, after I've set up any auxiliary controls, after I've done EQ, all the processing, panning, then we have the final output, which is the fader. Okay, and so again, after we EQ'd it and applied any effects or processing, that's measured in decibels as well. Over here, we have a master control. There's actually four. This is actually a live console, so we have four physical speaker outputs, and this is speaker 1, 2, 3, and 4. So you'd have two in the front of the stage, and two in the back of the stage, or something like that. And this may be the headphone volume for your headphones and some other ancillary stuff we don't need to worry about. But I just want you to know what a channel strip is and all of the functions. Okay. Oh, there's the master, and it could be the headphones. It depends on the type of mixer. I think this used to be called. This was like the Mackie 1604, and the headphone may be a knob in this case. I can't remember. It could be a fader. It varies on all different devices. They're very interchangeable the way they engineer these things. It used to be that we would send out those finished channels to a tape deck and record them, whether it was 1/2-inch 8-track tape or 2-inch 24-track tape. All right, and those would become tracks. And then we would take that and go to another mixer called the bus mixer, and then you don't need to know this, but you'd render it basically down to a stereo image for mass production, like on a CD or cassette or whatever. But not too many people are using tape now. People esoterically, they're like, "Hey man, I've got a tape machine, and it sounds great," and that's cool. I respect that, but it's really more of a collector's kind of thing. We don't really use tape decks for much else other than to simulate like retro kind of sound, because there's a lot of tape hiss in there. Okay. All the work we're doing in mixers, we still have an analog world that we live in. We still have these analog mixers, but we're trying to simulate those analog techniques with our applications in programs like Pro Tools and Reaper. Okay, so to recap, microphones convert acoustical energy into electrical. Speakers do the opposite. The three main types of mics available for our purposes are dynamic, condenser, and ribbon mics. We have pickup patterns that are used on mics to widen or narrow that area of recording. We talked about dynamic range, that swath of signal, right? The range of signal volume the microphone can handle from the quietest to the loudest signal. And the frequency response is the other kind of swath, the range of frequencies from the lowest hertz to the highest, and how accurately it can record those sound waves measured in decibels. We talked about pop filter with plosive and sibilant sounds. All right, we're always trying to get the best equipment possible to listen to and play back our audio, especially in game audio, because there can be a very dynamic experience when it comes to soundscapes. Speakers come in two types: passive, no power. They could blow out, explode, whatever, and active with a built-in amplifier and a fuse or circuit breaker. Headphones can reveal more flaws in audio because they're much closer. The speakers are much closer in proximity to our ears, and we're going to hear all kinds of other nuances in other areas of the frequency spectrum. The bass is going to be louder. And you want to consider, if you're using headphones a lot, to have an alternate mix for speakers and headphones, if you can. Two kinds of cables you might be encountering are unbalanced and balanced. There's no reason why you can't have both, but we always want to try to get balanced as much as possible. Going to be a little more expensive for balanced equipment, and cables, but it is worth it. The mixing console is where all of our analog signals are sent to. We adjust them, tweak them to our heart's content. We use EQ or equalization to adjust frequencies, the volumes of different frequencies, okay? And we use panning, and then finally our master fader controls, and we're routing it to some place. We can do routing to external effects, as I say here, with an auxiliary section, which we also can emulate in Reaper as well. All right. So there you have it, analog basics. I hope you enjoyed the lecture, and we'll move on next to digital.